This is Euclid Book 10, proposition number 75, and it says, if from a medial straight line there be subtracted a medial straight line which is commensurable with the whole in square only, and which contains with the whole a medial rectangle, the remainder is irrational, and let it be called a second apotome of a medial straight line. For from the medial straight line AB, well, this is a medial straight line right across here, okay? Let there be subtracted the medial straight line CB. We're going to subtract this line, and it is also medial. Okay? And this line is commensurable with the whole AB. But it's only commensurable in square. Okay? The lines themselves aren't commensurable, but if you squared them, they would be. And such as the rectangle ABBC. Now, where do we get the rectangle ABBC? Okay. We have a rectangle down here, two sides of which are going to be the length of AB, two sides of which are going to be the length of BC. That's where we get that rectangle. And you say, well, what about the rest of these over here? Okay, this is the square on AB. How do we get that? We took the length of AB, turned it into a square, and all four sides of that square are going to be AB. Same thing with BC. We took this length, made a square out of it. All four sides are going to be the same length of BC. Same thing with AC. Took this length, and we made a square out of it, and all four sides of the square are going to be the length of AC. That's how we got all that. Okay, so now let's go on. And such that the rectangle ABBC, which it contains with the whole AB, is medial. And this is by Euclid Book 10, proposition number 28. I say that the remainder AC is irrational. Let it be called a second apotome of a medial straight line. For let a rational straight line DI be set out. Okay, now we're going to draw DI right across here. And let DE, okay, the area DE is from here, from this line here to this line right across here. So this plus this together is DE. Okay. Now, that area is equal to the squares on AB and BC. So we're going to add this area and this area together, and those two areas combined are going to be DE. And we're going to apply this area DE to line DI. And we're going to produce DG as the breadth. And let DH, well, what's DH? From this line to this line. This area right across here. Not this, just this. Okay? And let DH equal to twice the rectangle ABBC. Alright, now, what that means is we're going to take the area inside of this rectangle, we're going to multiply it by 2, and when we do, we get the same area as this. And it's going to be applied to line DI, producing DF as the breadth. So DF is now the breadth of DI, or DH. So, therefore, the remainder EF, that's this one right here, this area right across here, not this, just that, is equal to the square on AC. This area and this area are the same. This is by Euclid Book 2, proposition number 7. Now, since the squares on ABBC are medial and commensurable, so if we add these two areas here, they're medial and they're commensurable. Therefore, DE is also medial. This whole area across here is medial. This is by Euclid Book 10, proposition number 15, and Euclid Book 10, proposition number 23, porism. And it is applied to the rational straight line DI. It's applied to this, producing DG as the breadth. Therefore, DG is rational and incommensurable in length with DI. This line here is rational, and it's incommensurable in length with this. And that's by Euclid Book 10, proposition number 22. Again, since the rectangle ABBC is medial, this rectangle is medial, therefore twice the rectangle ABBC is also medial. And this is by Euclid Book 10, proposition number 23, porism. So, not only is this area medial, but if you multiply it by 2, it still is medial. Good. And since this area is equal to DH, which is this right here, not this, just this, therefore DH is also medial. and it has been applied to the rational straight line DI, producing DF as the breadth. There's the breadth, DF. Therefore, DF is rational and incommensurable in length with DI. This is a rational line, and it's incommensurable with this, by Euclid Book 10, proposition number 22. And since AB, BC are commensurable in square only, okay, so these two squares are only commensurable when they are squares. They're not, okay, so line AB and line BC are not commensurable, but these squares are. Therefore, AB is incommensurable in length with BC. AB is incommensurable with BC. Therefore, the square on AB is also incommensurable with the rectangle ABBC. So, this square and this rectangle, these are incommensurable. This is by Euclid Book 10, proposition number 2. But the squares on AB and BC are commensurable with the square on AB. So if you add these two areas together, they're going to be commensurable with this. This is by Euclid Book 10, proposition number 15. And twice the rectangle ABBC is commensurable with the rectangle ABBC. This is by Euclid Book 10, proposition number 6. So, this area here is commensurable with twice of this area. Therefore, twice the rectangle ABBC is incommensurable with the squares on AB and BC. What that means is that if you add these two areas right here together, that whole total is going to be incommensurable with twice the area of this. That's by Euclid Book 10, proposition number 13. But DE, this whole area right here, this plus this combined, this whole area, is equal to the squares on AB and BC. If you add these two areas together, that whole area is the same. Therefore, DE is incommensurable with DH. Okay, so the whole area DE is incommensurable with this area right in here, excluding that. But as DE is to DH, as the whole area is to this, so is DG to DF. So is DG to DF. Okay? This is by Euclid Book 6, proposition number 1. Therefore, DG is incommensurable with DF. The whole length is incommensurable with this. This is by Euclid Book 10, proposition number 2. And both are rational. Okay? This whole length is rational. This from here to here is rational. Therefore, DG and DF are rational straight lines commensurable in square only. Therefore, FG is an apotome. This line right here is an apotome. This is by Euclid Book 10, proposition number 73. But DI is rational. This is rational. And the rectangle contained by a rational and an irrational straight line is irrational. Deduction from Euclid Book 10, proposition number 20. And its side is irrational. And AC is the side of EF. Okay. So, this is the side of EF. Therefore, AC is also irrational. This is irrational right here. And let it be called a second apotome of a medial straight line. And that's the whole proof. Alright, I will tell you more in a future video. Stay tuned.